When you use Azure Application Gateway, you're not just getting a basic load balancer, you're stepping into the world of advanced application layer traffic control. Let's walk through how it actually works under the hood so you can confidently design, deploy, and manage it. Every incoming request to your application starts at the front-end IP address. You can configure this IP to be either public accessible from the internet or private internal use only. You are allowed one of each, just enough to provide external and internal access flexibility. Once a request hits the front-end IP, it's intercepted by a listener. Think of the listener as a gatekeeper. It listens on a specific IP, port, and protocol like HTTP or HTTPS, and then passes the request along to your backend based on rules you define. You can use basic listeners for path-based routing or multi-site listeners if you want to route based on hostname too. For security, your listeners can manage TLS/SSL certificates, enabling encrypted communication. Next, your routing rules come into play. These rules link listeners to backend pools and specify how traffic should be routed. For instance, you can route based on the URL path like /video/* or hostname like api.example.com. You also configure HTTP settings at this stage, deciding if the connection between the gateway and your servers will be encrypted, whether session stickiness is needed, and how long the connection should remain open. Application Gateway operates at OSI layer 7, which means it understands and routes based on HTTP properties like host headers and paths. It uses a round-robin approach to balance requests among servers in the backend pool. You can also enable session stickiness if your app needs to keep a user's session on the same server, common in shopping carts and logins. Before traffic even hits your listener, you can place a web application firewall in front. WAF scans for threats like SQL injection, XSS, command injection, and more using the OWASP core rule sets. You can choose which CRS version to use, like 3.2 or 3.1, customize which rules are active, and even limit message size to avoid overwhelming your backend. Behind the scenes, your backend pool contains the servers that respond to user requests. These can be Azure VMs, VM scale sets, Azure App Services, or even on-premises machines. If you are using TLS SSL for end-to-end encryption, the application gateway will decrypt the incoming traffic, then re-encrypt it before passing it to the backend servers using their own certificate. When you're using Azure App Services, this TLS configuration is handled automatically. No need to upload certificates to the gateway. Azure Application Gateway supports two powerful routing mechanisms such as path-based routing and multi-site routing. Path-based routing directs /video/* to one pool and /images/* to another. Ideal for optimizing workloads. Multi-site routing. Host multiple domains like contoso.com and fabricum.com using the same gateway. Each listener listens for a different host name and sends traffic to the correct pool. You also get extras like redirects, such as HTTP to HTTPS or external sites, header rewrites, and custom error pages for branded user experiences. TLS termination at the gateway offloads the heavy encryption work from your servers. If you need end-to-end encryption, the gateway decrypts and then re-encrypts the traffic for secure backend communication. You control which certificate the gateway uses and how connections are authenticated. This also means your servers don't have to be directly exposed to the internet. Only the gateway is. That's a big win for security. To keep things reliable, the gateway uses health probes to check if a server in the pool is up and running. It sends test requests and expects status codes between 200 and 399. If the probe fails, the gateway stops sending traffic to that server, ensuring users don't experience failed connections. Your application gateway can auto-scale based on demand. You don't have to define how many instances to start with. It automatically adjusts up or down based on traffic. This means you are only paying for what you need and your app stays responsive under pressure. For modern interactive applications, Application Gateway also supports WebSocket and HTTP2 protocols. These allow full duplex communication over a single TCP connection, reducing overhead and improving performance for real-time interactions. Azure Application Gateway combines powerful routing, load balancing, TLS termination, web protection, and auto-scaling into a single solution. With rich control over listeners, rules, WAP, and backend security, you can ensure both performance and protection for your apps, whether they're in the cloud or on premises.